9.1, estimating a population proportion. Okay. All right, so first we want to be able to obtain a point estimate for the population proportion based on whatever they give us. So a point estimate is a value of the statistic that estimates the value of a parameter. So for example, here a population proportion is going to be p hat, and we want that to be x over n. So however many things happened out of our total amount, just as we've done before. All right, so for instance, here we have this organization, the Gallup. They conducted a poll. They had a sample of 1,015 Americans 18 or older. They asked about the income tax, and then 450 said yes out of those pieces. So our numbers there, 458 said yes out of the 1,015. Okay, so our point estimate there, p hat, is just going to be 458 divided by 1,015, and so we get 0.451 for that. Okay, so we would estimate that Americans 18 and older believe that they have to pay, what they have to pay is too high, and that it's a 0.451 proportion of those people. Okay. All right, so now we want to start looking at confidence intervals dealing with these things. Okay, so a confidence interval is an interval for a population parameter based on a guess along with those levels of confidence. Okay, and so the guess is our point estimate. All right, and our level of confidence plays a role on the width of our interval. If we have a low level of confidence, we're going to be close, but if we have a big interval, it's going to have a higher level of confidence because it's a bigger group to work with. Okay, now a confidence interval for an unknown consists of an interval of numbers based on the point estimate, and the level of confidence represents the expected proportion of intervals that will contain the parameter if a large number of different samples is obtained. Okay, now we denote that with 1 minus alpha times 100% because we always change those over to percentages. All right, so for example, here 95% confidence, our alpha would be 0.05 because 1 minus 0.05 gives me the 95% with those. Okay, so we would expect in a 95% confidence level that 95 of the intervals contain the parameter and 5 do not contain our parameter that we've come up with. Okay. All right, so just kind of a review on a few things here that we know about p hat. If we have our n times p times 1 minus p, and that's greater than 10, then we're going to be approximately normal, and also that our sample size is no more than 5% of the population size. Okay. Also, our mean, mu of p hat, will equal p, whatever the point estimate is. And then finally, our standard deviation, sigma p hat, is going to be square root of p times 1 minus p all divided by n. So those things hold true because we're talking about sample proportion here when we're dealing with this. That's what the p hat stands for. Okay? All right, now with our sample proportion, if we know it's normal, it fits our bell curve. Okay, and so 95% is going to be in between our sample proportions here of p minus 1.96 times sigma and p plus 1.96 times sigma. Now, that's our standard deviations at 1.96 p's. Okay, and so we could figure that out. Actually, we could take our chart and go back to our table. And if you look at the very bottom of those, tell you what, let's go over to Canvas here. We have that table here under Z table. We let it load. And if we go down to the very bottom of this Z table here, you'll see that we have some confidence intervals on those, okay? And so right down here, we'll see those. And so when it said 95%, we had a critical value of 1.96. That's where that's coming from, okay? All right, And so since there's 95% there, that means there's 5% left over. If we divide that into the two tail pieces, that's where the 2.5 comes. So our proportions should all lie within this blue area, or 95% of them should, and 5% should lie outside if we have a 95% confidence. Okay. All right, so our confidence interval typically is the point estimate plus or minus the margin error. That's what's creating our end pieces. Our point estimate goes in the middle, and then if we subtract off our margin of error, that's the lower bound. If we add the margin of error, that's our upper bound for those. Okay. All right, and so if we could move things around, but we would see here that our P should end up within at 95% on those. Okay. All right, so let's talk about what that means again here. 95% confidence level. So suppose that we have 200 different random samples of size 50 with P being 0.7. All right, so we're going to move to this next slide in just a moment. And so the green intervals include the population proportion. The red do not, okay? And so we would see, as we did this simulation here, that anywhere we have a red dash, the population proportion is actually not in that piece, okay? Because whether it's too small being on the left-hand side or too large being on the right-hand side of our line of 0.07 for those. And so there's not very many of those because we're going to have a pretty big confidence interval there. Okay. All right, and so this is just more description of those pieces. So a 95% level of confidence means that 95% of all the possible sample results in confidence intervals that include the parameter being our point estimate for those things, okay? And 5 do not include. Okay? Now, the confidence interval does not mean probability. That is P, okay? Or mu on those types of things. So we got to make sure that we're paying attention to what those things really mean for those. All right? Now, the confidence interval contains the parameter depends solely on the value of the sample statistic. Okay, and so we want to make sure that we pay attention to those details. Right, so again, here's more of the same type things. Now, that critical value again, Z of alpha over 2, it's our critical value, so we just looked at that on our table. You can go and find that Z table right in Canvas there for those. So I would print that. That doesn't always show up in your homework, so if you've not already printed this, go to campus and print so that you can have one, your Z table, but two, your confidence interval critical values here, because we're going to use these quite a bit in your homework. Okay. All right. So again, your confidence interval here, dictated by 1 minus alpha times 100%, tells us, indicates that percent of all random samples of size n from the population whose parameter is unknown will result in an interval that contains the parameter. All right, so let's kind of take those things. So again, looking back at that poll there from Gallup, we had 1,015 adults that were sampled, and we can say that we have a 95% confidence level that the maximum margin of error is 4 percentage points. All right, so what does all of that mean? All right, so our point estimate we determined earlier was 0.451 when we were doing those. Now again, we got that as well right up here. We can see these pieces. So if our point estimate was 45.1%. We calculated that earlier as well in previous slides. Okay, so we change that over to a decimal, and we get that 0.541. Now the margin of error is 0.04 because it said percentage points. So on those, so when we read that, it said here percentage points. So 4%, we change over to a decimal, we get 0.04. All right, so our confidence interval we would have the 0.451, we would add and subtract with those. So when we do our subtraction, we get the 0.411, that is the lower bound of our confidence interval, and we add 0.04, so we get 0.491, that's the upper bound of our confidence interval, okay? All right, so we believe here that 95%, we're 95% confidence that the proportion of Americans aged 18 or older who believe that the federal income tax is too high is between 0.411 and 0.491. Okay, so we know that we could use that information, right? All right, now, how do we find those pieces otherwise when we don't have all the information? So we can do the calculations just like we did a moment ago, but we got to look for some things. So this is the official definitions. Again, we're going to use the calculator to make these things work. Now, margin of error is also right here, but we'll talk about how we can do that in the calculator as well. Now, if you notice this formula, if we go back one, the second part of this here on both of these is that E. Okay, so that is E on both of these formulas with those. And so it's the P hat minus E and P hat plus E. So kind of like we talked about just a moment ago for those. Okay. All right, so let's look at how we can do this. Now, the first one, they do it by hand. They say here that we have 800 selected in our sample. Of the 800, 272 indicated they text while driving. So that's kind of our big number there for those pieces. We want a 95% confidence interval for this proportion. Okay, so what is going to be our upper and lower bounds here? All right. Now, if we're doing it by hand, we need to first calculate P. So we get the 272 divided by 800. Okay. We verify that it's normal. And we see that it is. So we have a P hat of 0.34 with those. Now, if we go and look, if we were to look back at our table, we said 95% confidence. So let's go back over into Canvas here. So again, 95% confidence gives me the 1.96. So that's where they came up with this 1.96. If we needed other ones, they're going to stick typically to those 4 that are in your table. Okay? And so then they go through and they do the lower bound here by hand with those pieces. Okay? And then as well, the upper bound. Okay? And now we know, because of what we're adding there, that the margin of error, but once we do it by hand, is this other piece. Okay? So we know that we're always going to have that piece, which is actually this, is our margin of error. So we can see that there. Okay? All right, so that we're 95% confidence that our proportion is going to be with 0.307 and 0.373. Okay. All right, now what about technology? Now they go through and do this using looks like or StatCrunch, sorry, for those. And so we're not using StatCrunch. We're going to use the calculator over here. And so let's look at how we can get our calculator to do this piece for us. Okay. All right, so what we're going to do here is the first thing is we're going to go to Stat. So we need to select Stat, do Stat, and then we're going to move over to Tests. So over to Tests. Now we're going to go down until we find 1 dash prop Z INT. Prop Z INT. Now make sure you select the right one. You'll notice that it's all the way down here. I have it as A for mine. Okay? All right, now, I was practicing this problem earlier, so that's why my numbers are already there. But our X value was the 272. So we would just type in 272. Our N, our total amount, was 800. And we wanted a 95%, so 95% is 0.95. That's our confidence level. That's what C level means. And we press calculate. Now again, you'll notice here, our lower bound is the first one, and our upper bound is the second one. And if we round those, we still get the same answers that they did of 0.307 and 0.373. Okay. Now, it also shows us p hat there, if we needed that for anything. And then if we need to get our error, what we can do is we can take our upper bound and subtract the point estimate. Okay, and that's even stated here when using StatCrunch, but calculator, the same thing. So if we take our upper bound and subtract the point estimate, p hat, so we take our upper here, subtract our 0.34, we get the 0.033, which is what they've done here as well. Okay, so we would subtract the upper, and so here in this statement, the difference between the point estimate and the upper bound. So the upper minus the point estimate for those. Okay. All right, so again, we still have the same numbers there for those. So based on whatever they ask, we could find those pieces with just a little addition and subtraction. All right, now, earlier, that logic suggested that a higher level of confidence leads to a wider interval. Okay, so we always want to remember that. If we have a pretty high level of confidence, so we were talking about 95, if we went to 99, it would be even further. Okay, and so that's what they do here in the next problem. They said, hey, we want to increase this. What if we go instead of 95%, what about a 99% confident for those pieces? Okay, now they're doing it again by hand. They go through and do all those pieces, but what about our calculator with those? So again, we do stat, we're to tests, and down to one prop z interval. And so this time we just need to put in 0.99. Okay, and so we get now that we have an interval of really 0.297 and 0.383. Okay. All right, so our midpoint there, our p hat is 0.34, so that's given to us. And then again, if we take the 0.34 and we subtract the lower, or we take the upper and subtract 0.34, it doesn't matter which one. It's always going to be the positive, though. Bigger minus smaller. You can work with either problem. They decided to use the lower bound instead of the upper bound. It doesn't really matter when they were doing it, but they still got a margin of error of 0.043. Either one of those will give you the same answer. Okay. All right, so we increased our confidence interval with those. All right. So we can see if our sample size decreases, increasing the sample size decreases the standard error on those. Okay. All right, now what about finding the sample that we need for a certain confidence interval? Okay, how many people do we need to be sampling in order to create that? Okay, and so this is a formula that we're going to need. N equals p hat, open parentheses, so times 1 minus p hat, and then times our z sub alpha over 2 divided by e, our error, all squared on that piece. Okay, and you're going to have to know that formula. All right, with those. So it depends on our p hat on those. All right, so we need to figure out those pieces when we're looking at those. Now, we also have here, what if we don't know what p is? Okay, so here we know p in this formula, p hat or p on those. But what if we don't know that? Then we're just going to use 0.25. Okay, so if they tell you it's unavailable, that information is not available, you're going to use 0.25 times that z alpha over 2 divided by e squared. Okay, and we always round up for those. All right. Okay, so here we have a sample size, and we want to estimate within 2 percentage points of the true population with a 90% confidence. If part A, we have a point estimate of 10%, and then part B, we're not going to know. Okay? All right. Excuse me. So, things we need. So, E is 0.02 because it said 2 percentage points when we look back here. So 2 percentage points, we got to change that over. Now, if it says 2 points, we use 2. The 2 percentage points is 2%. We change that over to 0.02 for those. Okay? Now, our Z of alpha over 2, notice they got 1.645 because it said 90%. If we go back to our table here, we look at 90%, we get 1.645 right down here at the bottom. It matches with our 90%. Okay. All right, so now we can plug those things in. Now our P hat is 10% or 0.10 from those. And then we do 1 minus the 0.10, 1.645 over 0.2 all squared. And then make sure putting those parentheses in when you're doing the calculator with those. And that means that we need a minimum of 608.9. Now we always round up for this to 609. Even if that said 0.001, we would round that up. You always got to round up on these problems when you're looking at them, okay? All right, now, what if we don't have any prior estimates? So this time, we're still going to use the E and the Z value there for 90%, but we're going to use 0.25 in front of it. And so that means that we have 1,691.3. Now again, we round up, and so we must have 1,692 in order to get a good 90% interval on this, okay? So that's what you're going to look for there on those pieces. All right, so makes a big issue there if we don't have our prior estimate when we're looking at those. Okay, so those are the things that you're going to need to know here for 9.1.